This is Trekzone's Talkin' Science.
Welcome to it live. Trekzone membership is available via the join button under each video on YouTube or via the trek.zone/support. Plus Trekzone's on Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow and subscribe. Welcome to Talkin' Science. We are currently in an indefinite hold at T-minus 10 minutes at Cape Canaveral, launch pad 39B. Artemis and the Space Launch System is sitting there ready to go, but it cannot leave just yet. Tanking continues. Liquid oxygen tanks are at 95%. That's the last of 4 tanks that need to be completely filled ahead of launch. Cryogenic tanking even has caused delays through the evening in Cape Canaveral, the US East Coast. It is now just past 1 a.m. In Florida. Engineers on the red team had to carry out work on the pad earlier this evening. The range is now the issue from what we understand. The flight path needs to be cleared. So while we wait for further information, let's catch up on the last step of Talkin' Science, where Dr. Brad Tucker joined me, and we carried on our discussion about science. This is Talkin' Science, catching you up on the month's biggest stories with Dr. Brad Tucker. Australia signs on to a Japanese sample return mission. In 2029, we'll have the first ever samples from Phobos. The largest massive impact crater in 16 years has been found on Mars. And speaking of large, meet 2022 AP7, an asteroid ranking in the top 5% of all-time biggest potentially hazardous objects, and it could get in Earth's way the next few hundred years.
This is Trekzone's Talkin' Science.
Your monthly reminder that Trekzone membership is available via the join button under each video on YouTube or via the trek.zone/support. Plus Trekzone's on Twitter, Facebook, Instagram, and your favourite podcast feed. Find us everywhere, like, follow and subscribe. We now have super thanks enabled on the channel as well. It's the ability to contribute without becoming a member. Support us make more great content. Brad Tucker is here. He's on social media at btucker22 on Twitter, Dr. Brad Tucker on Facebook. Brad, welcome back to Trekzone, my friend. First up,
How's
a quick
it going?
mention of very well, speeding through everything. A quick mention of tonight's blood moon, if you will, sir.
Yeah, look, if you're in roughly a third of the world, you'll see a blood moon, which is always convenient. Visible in Australia, New Zealand, Asia, most of the Americas. Sorry, Europe, you miss out, but you had a partial solar eclipse earlier, so I don't feel too bad for you. Yes, happening with the moon passing into the Earth's shadow, and you get this red color because a little bit of sunlight skims the Earth's atmosphere, goes off into space and lights up.
It's week 44 of 2022.
Here and solar eclipse earlier, so I don't feel too bad for you. Yes, happening with the moon passing into the Earth's shadow, and you get this red color because a little bit of sunlight skims the Earth's atmosphere, goes off into space and lights up the moon. So it's a really cool phenomenon. You don't need special equipment. You just need to go outside and look. You can check online, places like timeanddate.com and things like that. You can enter your location and find your exact timing of it.
And also, you mentioned no special equipment required. I think with this one, we need super yachts and to be in the middle of the Pacific Ocean to get the absolute best position. Is that about right?
That's the absolute best position, but really, as long as you're somewhat covered, you will mostly be okay. New Zealand is pretty well centered, but for the most part, you'll have a fairly good view of it.
All right, well, let's get into the show. The 9th Chinese space station-related mission since April last year took flight last month, completing their ambitious station in orbit, Brad.
Yeah, we mentioned when they said, hey, they were going to try and finish this by the end of the year, and look, it was an ambitious timeline, and they've managed it. This was that final main part of getting up, that last module, as you said. There's still some work to do to complete it, but they already have an astronaut, or a taikonaut crew rather, up there on their space station, the Tiangong space station, to complete it. So it will, unless something happens, be operational by the end of the year. In fact, with a little bit of room to spare. So, they, as we've mentioned before, are powering through in some of these areas.
We now know who will be joining NASA's Unidentified Aerial Phenomena Study, the space agency announcing the team a couple of weeks ago, Brad.
They did. And, it was a variety of people from across the board and expertise. A few close colleagues I know, Fed Bianco, who works on supernova like me, but also does some things into urban planning. Nadia Drake, who's actually a microbiologist by training, but writes regularly for National Geographic, and is the daughter of Frank Drake, who came up with the original Drake equation for times of life, but also ex-military, ex-NASA pilot Scott Kelly, the famous first American to spend about a year in space, and expertise all in between. So a very diverse panel in terms of scientific background and technical expertise.
Let's keep moving on the show. The Australian Space Agency has agreed to collaborate on the next Japanese sample return mission, Brad. The precious cargo will land in South Australia, just like Hayabusa 2 and Hayabusa 1 at the end of this decade, and the capsule will contain samples from a place we haven't been to yet.
That's right. The moons of Mars are very different in a lot of ways than our moon. They're tiny. Our moon is a little bit smaller than Australia. Those moons are smaller than a city. They're only 16 and 25 kilometers wide. We think they're captured asteroids. They orbit so close to Mars that they're actually closer than our geosynchronous satellites around the Earth. They are very close. And so because of this, the idea is, well, we don't really know a lot about these moons. Let's go and study them in detail and land and grab samples. But also because of how close they are, there's a belief there may be some rocks and samples of meteorites that have crashed into Mars, flown out, been ejected out, and actually landed on those moons, so that you could potentially grab some Mars rocks as well, in addition to the rocks of the moons themselves. So very unique, very ambitious, and an exciting mission as part of this growing cooperation between JAXA and Australia.
Now, with the timeline, you can tell JAXA have great confidence, the Japanese Space Agency, and experience as well in this. We know that they've done Hayabusa 2 as well. They're planning on launching MMX, launching September 2024, landing on Phobos in August 2025, and returning to Earth in July 2029. It's almost becoming the start of a decade-long tradition. Hayabusa in 2010, Hayabusa 2 in 2020, and now 2029 for this MMX mission, Brad.
That's right. Yeah, and this is kind of the exciting thing, is you can make these missions kind of turning them out quite regularly. And the hardest part to some degree here is just how long it takes to get to Mars. These timings are because it'll take 6 months alone-ish to get to Mars, and then you have to wait for the orbits to line up back. There will also be other countries that have cooperated, just as Hayabusa 2. CNES and DLR, the French and German space agencies, will be building a probe to land, a rover to land on Phobos, the moon as well, just as they landed some craft on Ryugu with Hayabusa 2. They're also working with Japanese television to produce the first 8K television images of the moons of Mars and Mars itself. So, our views of Mars are going to get a whole lot crisper coming there. And so these are the cool things that you can do just by the sheer amount of cooperation, working together. And so this is definitely a great mission for Australia to be a part of.
I'm just thinking of our friends at Tidbinbilla, Glenn Nagel and everyone having to process that 8K data as it beams down. That is going to be a huge file for them to download and have loss prevention on.
Yeah, so I think people may be retiring towards the end of the decade, so they don't have to deal with that. I don't know. But yes, no, there's a lot of work that will happen as part of this. And as you said, broadly across lots of sectors in Australia. Some of these samples, as with Hayabusa 2 from the Mars mission, will stay in Australia to be studied by Australian scientists as well, with both places Phil Bland and Curtin and Trevor Ireland at University of Queensland being involved in these past and future missions. So really exciting opportunities as well for the science to evolve and happen, and Australia is part of it.
Now, we've spent a long time looking at Mars, exploring the red planet surface, orbiting, roving, and even droning. But this will be the first mission to a satellite of Mars. What are the burning questions right now that the Martian Moon's Exploration, MMX, hopes to answer?
So there's a few, right? There is, exactly what and how are these asteroids made up of. We believe they're captured asteroids, but we're not exactly sure. Is there any sign of its history? There's some models that suggest the moons of Mars are slowly migrating towards Mars and may actually, and probably will, due to its gravity, break up in 20 to 40 million years. And as they break up, they'll kind of spread this huge area around as a ring almost. And some models have suggested that gravity has actually brought that back together to form almost a cyclical moon potentially. So a little bit about their history, the history then of Mars itself. If they can find Mars rocks, then that could be signs of massive bombardment by meteorites on the planet itself. So a huge range of different things there. And, we've spent a lot of things of rovers landing on Mars and studying them and samples of getting it back, but the moons have been neglected. And so if you want to understand the entire planetary system, just as you need to study our moon to help understand Earth, you need to do it with Phobos and Deimos as well.
And for a long time, the planets of our solar system were the focus. Now we seem to be shifting to the moons, planning underway for Titan and Io missions, and now Phobos. In general, as overall, what can the moons of the planets tell us? As you say, studying them helps us to understand the planets, but kind of, I guess, what are we looking for when we're studying these moons?
Yeah, there's a lot of interesting debate about the formation of moons as well. There seems to be multiple paths to some degree of how a moon can turn into a moon. Migration, moving towards it, being captured, being formed from a collision, or form completely different mechanisms like Jupiter and Saturn, which appear to be, their moons are larger than in some cases Mercury, and they have atmospheres. And so it's that interesting dynamic between the moon and the planet itself. And then obviously, is there signs of life in some of these places? So it's, there's 120 something moons, I think, or so in maybe 130 in our solar system. That's more than the 8 planets we have. So that means there's a lot of bodies which are all very, very different. And then why also does Mars have moons at all? Mercury and Venus do not. Earth does. And Mars does as well. And again, Mars's moons and our moon appear to have very different past histories. So that tells you a lot about the planet itself. Does it give insight into the tilt of Mars? Just as studying our moon gives insight into the tilt of Earth. So there's a lot of these different things that really start to build up the picture, both of potential exploration, the idea of life and habitability, and the creation of the systems themselves.
Well, just before Christmas last year, NASA's InSight spacecraft had a front row seat to a pretty spectacular sight. It's staying with Mars, but moving on to our next story. It's seismometers measuring seismic waves as they reverberated across the planet. Brad, what caused that? Yeah,
and this was from a fairly massive meteorite impact. It left a crater about 150 meters wide, visible on the planet. And as you said, a seismic wave traveled all around the planet and detected by InSight, which was in the different hemisphere. It was in the southern hemisphere, as opposed to the strike, which happened in the northern hemisphere. And this is actually something the scientists on this team have been waiting for. InSight has been designed to measure waves, seismic waves and activity underneath the surface of Mars. They've detected Mars quakes. They've detected some meteorite impacts, but very small ones. They were trying to hope to discover a wave that traveled from the other hemisphere and all around, so they can actually study more of the underneath of the surface of the planet as a whole. As that wave travels around, you can monitor what's going on. So it was definitely a well-earned Christmas gift for all the team.
And scattered around the impact crater that measured 150 meters wide were blocks of water ice excavated by the force of that crashing meteorite. That was a pretty special find because it's closer to the equator than anything previously discovered.
That's right. We found signs of ice slightly underneath the surface before. Obviously, there's carbon dioxide and other ice at the poles. As you said, not only was this deep, but it was very far away in its location. And this, again, goes to the geology of the planet. If you look at Mars, the northern hemisphere of Mars is very different from the southern hemisphere. The northern hemisphere is low-lying, believed to be volcanic lands. The southern hemisphere is highlands bombarded by meteorites, and also some volcanoes. So very different geology. If you look at Earth, we're fairly even hemisphere-wise. It's very different on Mars. And so there's been a question of exactly, is this the case? Is the composition underneath the different? is the ice similar near the equator and far away from the equator and between hemispheres. So it was a unique way of probing a very different part of the planet that we haven't been before, but also that the probe wasn't and couldn't. It doesn't move. It's just sitting there. So it was a great opportunity to get a lot more insight into Mars.
Now, I was reading a little bit about the Mars dichotomy mystery that you're alluding to there. Why is the North so different to the South? And the Mars Reconnaissance Orbiter also traced the source of another seismic wave a few months earlier. That was to a 130-metre wide impact crater, about 7,500 kilometres away from InSight. And these two events are helping to shed light on the internal structure, answer that dichotomy mystery as to why North and South are so different, aren't they?
That's right, because they can see how the waves move around, and depending on the composition, you can see how the wave moves. Does it move through different pockets in the hemisphere, either longitudinally around or latitudinally up and down? And then get insight into what it's measured locally. Because it does appear to be the case that it's a fairly smooth, uniform northern hemisphere, more from volcanic flows almost. Where in the southern hemisphere, it's very clumpy and more clay-like. So the densities in the waves move slightly differently. So as you said, by having these two move around the planet, you got very interesting data multiple times, again, which is A, what you want, and B, making sure there was nothing based on the location it landed, the impact itself, and again, a bit of that latitudinal position on Mars. And this was one of the big science goals of InSight, was to try and do this. They just had to wait for 3 years to get their data.
And this could all add to mounting evidence that Mars is still volcanically active. You're sort of alluding to it there a little bit, but yeah, we could actually still have an active red planet.
And that was always the case, is not just, what are these layers like? How deep are the layers? These have been some of the other questions that InSight has been studying. But yes, is it active underneath the surface? And you get insight into that based on the quakes they measure. What are the nature of the quakes? Because there's different types of waves that move due to seismic activity. And is there signs that it could still be volcanically active? We know there's a lot of volcanoes on Mars, and they're more akin to hotspot volcanoes, like you would get, say, in Hawaii or Tonga, where you get a hotspot that comes up underneath the ocean, different than some of the other volcanic activity in the other solar system. So you can look at places like Io and other moons that have slightly different mechanisms, and some that are similar. And then this is also useful for trying to even understand a place like Venus. We don't understand a lot about Venus. It has this runaway greenhouse. There's a lot of debate about whether it had volcanism in the past. Is it still active or not? So all of, by studying Mars, Earth, and Venus, you get different extremes of the problem. And that's why we're interested in this. You can kind of see, is it, if Earth really is in the middle, where we use it as the base point, is it more extreme one way or the other? And by having such different planets between Venus and Mars, you can really get that data, which is also why a lot of people are talking more and more about studying Venus as well.
Just going to pause our replay of Talking Science from last week. An update has come through from Mission Control. A new issue has arisen. The liberation of cork between Orion and its solar panels is now presenting a problem. They're likely loose and could fling off in flight. Now, this issue arose after Hurricane Nicole blew through and delaminated several panels earlier in the week. That was the reason for the delay from Monday. The team determined, that is, of course, the launch team over at NASA, all those smart cookies over there, determined that it could dislodge following a launch. They have now evaluated that the risk is negligible. So we're just waiting to see what happens there. It is a 2-hour launch window today. That closes at 3:04 a.m. Eastern Time. That's 6:04 p.m. here in Brisbane. So we are about 15 minutes into the launch window as it stands now, that 2-hour launch window. At this stage, there is no progression towards the polling for go, no-go for launch, which was supposed to happen at T-minus 15 minutes. We have entered that T-minus 10-minute hold. It is indefinite at this stage. There was an issue with the range as well. The 45th Space Wing from US Space Command were having issues with their radar. That radar system allows them to send a remote destruct command to the rocket should there be any issues, and they were unable to do that for a period there as well. So plenty of issues arising here with the very first launch of the Space Launch System. Just bring you back to showing you the Cape there, live shots from the NASA media channel of Artemis. She is standing ready for launch. Unfortunately, problem after problem is presenting itself. So right now, let's take you back to myself. I'm just going to cut, but that's how we're going to do it. What I can do actually is we can go this way, and we'll take you to the Cape now, and I will resume talking in the past from the previous episode of Talkin' Science with Dr. Brad Tucker. Our last story. We will continue to have standby content throughout this afternoon for this 2-hour launch window. I do have dinner to cook, but rocket launches don't happen every day. Well, they kind of do, but not quite yet. But this one is a very significant one, and that 2-hour launch window closes at 6:04 p.m. Australian Eastern Standard Time. That's 7:04 p.m. for Sydney and 3:04 p.m. for Perth on the west coast of Australia. So let's keep going. Let's see what happens. But right now, let's take you back to Talkin' Science from last week. It's week 44 of 2022. This is Talkin' Science. It's week 44 of 2022. This is Talkin' Science. Now, as it turns out, our production software here doesn't like me doing that. It likes to automatically restart each time, which you don't want to see the whole thing again. So let me just quickly spool forward through here to
really get that down.
We are talking. We'll turn that audio off so that I can frame that up exactly right. And we are going to return you to Talkin' Science from last week. One more story to go as we continue to wait for... let me just make sure all of my little triggers are turned off here. We don't want that restarting once again. So we are waiting for the launch of Artemis 1. Delays continue. Not only did we have tanking issues earlier in the night, we have had a radar issue with the 45th Space Wing, who maintain the integrity of the flight zone. We've also now having issues with the liberation of Cork. The technical definition is the liberation of Cork from the Orion capsule to its solar panels upon launch, that very violent launch of all those rocket engines launching. So plenty of problems for Artemis. I will bring in Brad with our pre-recorded chat from earlier today once we sort of get an idea of where we're heading with this launch. Right now, though, let's take you back to Talkin' Science from last week. Just time to dive into the planet-killing asteroid on the way to us, Brad. 2022 AP7. It's been found. It's on the other side of the sun, and it's one of a trio that's been discovered.
We know there are asteroids that we're missing. We can kind of measure it through a variety of mechanisms, and we know that we're incomplete. And we're incomplete based on sizes. So we know on the tiny ones, we don't know a lot of them. On the really, really big ones, we're fairly complete. The more medium-sized ones, the couple of kilometers to hundreds of meters, we know, again, is somewhere in between. And part of this has to do with our visibility of finding them. We generally look away from the sun because that means we have lots of nighttime and we can see these objects moving. But we also know that objects can exist near the sun as viewed from us. And if they're kind of always hanging out in that same spot, they can kind of be in your permanent blind spot. We kind of usually imagine that they'll eventually move around the sun just like we do, and at some point we'll be able to see them. But if they're always kind of in our blind spot, we will always miss them. And that's the case of this. And in order to see this, they had to look just around twilight time. So just either right before the sun rises in the morning or sets in the evening, where the objects are very close to the sun, but you can just make them out. And that's where these three were discovered, in this proverbial space blind spot. And as it turns out, at least one of them is quite sizable. And one of them is definitely of the class of these Earth-crossing asteroids. It regularly, in its orbit around the sun, crosses the path of Earth, which is obviously what you want to monitor because those are the ones that you worry about.
Yeah, absolutely. Well, we should declare that the risk right now is low, but in the centuries to come, we'll likely need to have perfected the lessons learned from the recent DART mission.
Because it's kind of slowly in its movement, still in that blind spot, it's going to stay out of our way for, as you said, for centuries. We also don't have a lot of data on it because it was only recently discovered. Now that we know what to look for, you can kind of keep track of it, but it's still hard to see always being near the sun. Now, the example is, if you ever try and look at the planet Mercury with your own eyes, it is visible, but it's so close to the sun with respect to Earth, it's really hard to see. You only have a small window of seeing it every night. Venus is a lot easier to see. Places like Jupiter and Saturn, you can see quite a lot. And this is the case with this asteroid. You will always have a small visible window of getting data, better measuring that orbit. And as you said, as of now, it doesn't pose any risk for centuries, but it is one that probably will pose a risk in the future. And because of its size at roughly 1 to 2.5 kilometers, can do sizable damage if it were to hit the Earth. It's much bigger than the one that DART was tested on by a large fraction. But, that's the whole point of that DART mission, was to see, at the very least, if it works, then, all right, well, maybe we need 5 darts or 10 darts. But at least one will do a little bit, and then you can repeatedly do it and do it more, or you can change the nature of the mission as well. So this is part of this doing in tandem, is you have to find the asteroids and you have to find a plan what to do about the asteroids. It's no good just finding them and not having a plan. And it's also not good having a plan, but not finding them, because if you don't know them ahead of time, you're out of luck. So, it may take that we need to start nudging it 100 years in advance to save Earth. So you have to know, A, how much you'll need to plan it by, and you have to find it a couple hundred years in the future in order to plan it. So it seems very long-term, but this is the way it has to work in space.
Well, Scott Shepard from the Carnegie Institution for Science in Washington led the team that made this discovery. He said in his submission to the Astronomical Journal that they expect to find more in the next year or two. Now, it's something that I still struggle sometimes with, Brad, to wrap my head around, is that asteroids in our solar system, they're not just in a neat bunch around Mars and Jupiter. So how worried should we be about a potential planet killer out there going unnoticed?
I mean, there's always a bit of a worry, but, we do know of very clear parts where these asteroids hang out. And we know kind of the groupings of them in the populations. And so this is also the helpful thing. If you find 3, clearly there's a bit of a population out there. So you can keep monitoring that area throughout the year to keep finding them. As you said, Scott and his team will be doing this. And this is using just telescopes that we use to find supernova in Chile. And again, and this is kind of the cooperation of these international facilities. The sky is too bright for us to look for supernova and black holes and other things, but it's not too late for them to do their work to find these asteroids. So this is where a lot of these facilities, in terms of their operation, have changed to benefit all this. So instead of staring at it all night, where, all right, during the middle of the night, we probably don't need to find asteroids, and we're actually going to find them looking for supernova anyways, let them be dedicated to finding asteroids then, and then we can do our work. And that maximizes the operation of the telescope, maximizes the science, and sharing resources. And this is exactly how this has happened. So it's a really great way of doing science these days, is collaborative, different science cases come together to do joint facilities. And so even though we know there's more asteroids out there, we're getting more clever and we're building more telescopes and systems to find them better. And this is where, we're headed. And part of this has to be concerted effort. And lately the problem has been, no one has really felt it was their responsibility to do this. People like Scott has also been studying comets and TNOs. That's been a lot of his work. So this was kind of a unique chance as part of his work to find these things. And so you don't have to build a dedicated facility. In some cases you do, but you can do the sharing that maximizes return on discovery.
And I guess in terms of risk and worry and stuff like that, we should probably look at our low Earth orbit first with all the space junk that's around that. And maybe if there's an asteroid that swings by, it might just suck up some of those and we won't have such a big orbital problem.
Yeah, look, there's a variety of issues. In generally speaking, people are not that worried about asteroids, right? You know, we do know of them. We do know of the ones. And again, yes, we don't know of all the small ones. But the small ones aren't going to do that much damage if it hits Earth. The big ones, the really big ones, we're pretty good at finding. Yes, we need to work better on the medium ones, but we do know we can find them well ahead of time. And so this is all part of the work and all part of the plan, and why that DART mission was both important, but also why there's other issues that you have to deal with. Solar storms as well. There's a number of them. So not things you necessarily have to lose sleep over, but things we do have to study and work on, just as we study weather and monitor earthquakes on Earth. You have to do this in space as well.
Absolutely. And train up the next generation of oil riggers.
That's right.
I love it, Brad. It is great to pick apart the past few weeks with you. We've been doing it the last couple of months. 2 more episodes to go before the end of the year. Absolutely incredible. 2022 has flown.
It's been busy, but it's nearing the end. Gearing up for an even busier 2023.
Absolutely, Brad. We'll catch you at the start of December.
Thanks.
A live update for you now. That is Talking Science from last week with Dr. Brad. We are hearing from Mission Control that we are just a few minutes away from polling being able to resume. From the Mission Control team, we saw a shot there of firing room 1 with the launch director at Cape Canaveral. Let's bring in that audio now and just see where they're at. There is an update underway.
The upper stage of the rocket, which was the last to get ready and configured. Just recently, the team cycled the liquid hydrogen valves, which is required. And they are currently working on the LO2 valves, liquid oxygen valves in the upper stage. That work is almost done. We are now a minute and a half away from the poll of the mission management team, which is several minutes before T-minus 15 minutes. When that poll starts, we'll get a clearer picture of our T0.
So we continue to wait for that polling to commence.
NASA's test director has informed the launch team to all switch to a common communication channel. It's called 232. And what this means is that the entire launch team is now on one channel, and all future communication will happen there. Whereas there are many channels. Now they reduce it down to one. Just heard from NASA test director Carlos Monge. I'm sorry, Jeff Spaulding. Jeff Spaulding's on. They swapped out. There are currently no constraints to launch. Great news. Again, no constraints to launch. And they're getting ready to pick up with a poll to determine readiness for launch.
So we're just waiting for that polling to commence. That will give us our new T-0 count. Our launch time from Cape Canaveral Launch Pad 39B, the Space Launch System, and NASA's Artemis 1 mission, the uncrewed test flight, which will take us to lunar orbit and back to Earth. A 21-day mission to prove all the systems on board this massive
NASA
rocket.
Test Director Jeff Spaulding getting ready to conduct the readiness poll, so we are getting close. We're going to pull up the audio now so that you can listen in.
Rockets go. All right, copy all. And Launch Director NTD, our launch team is ready to proceed at this time.
I copy all NTD. At this time, I will proceed with my poll. And attention on 232, this is the Launch Director performing the final poll for launch. Verify no constraints and go for launch. EGS Program Chief Engineer.
EGS Program Chief Engineer verifies that the EGS, SLS, and Orion Program Chief Engineers have no constraints and are go for launch.
Copy, Greg. Thank you. EGS Chief Safety Officer.
The EGS CSO verifies the SLS, Orion, and EGS CSOs have no constraints and are go for launch.
Copy, John. Thank you. Range Weather.
Weather has no constraints and weather is go for launch.
Copy, LWO. And Mission Manager. And Mission Manager, Launch Director.
Launch Director, Mission Manager on 232. The mission management team has been polled. You have a go to proceed with terminal count and launch of Artemis 1.
I copy all. Thank you. And NTD, Launch Director.
Go ahead, Launch Director.
Yes, sir. On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, and for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis 1.
Copy, Launch Director, and thank you. All right, we do have a couple of steps to configure, and then we will be ready to resume the clock. CVSE, NTD. CVSE here. Initiate recording of Orion cameras at this time. In work. NTD.
RSR here.
Perform the booster ignition SNA arm rotation enable.
NDT, RSR, booster ignition SNA arm and rotation enable is complete.
And I copy. Thank you.
Okay, so there you heard the poll from Launch
All right,
Director.
and all personnel, we are going to resume the clock here momentarily.
Getting ready to get that new T0 time. The poll that you heard was the NASA Test Director's poll. And
all right, and we have verified no cutouts at this time. And all personnel, we are going to resume the clock. GLS, you can resume the clock on your mark.
GLS copies. Countdown clock will resume on my mark. 3, 2, 1, mark. GLS mainline has been initiated.
okay,
T-minus 10 minutes and counting.
we are T-minus 10 minutes away from liftoff of Artemis 1. As you can see, the clock is now moving. Let's put that up. T-minus 9 minutes and 47 seconds. The L-minus 15 poll complete.
Show
It went
06:47:44 is the new liftoff time.
Affirm.
Okay.
Oh 01:47:44, 1:47 a.m. Eastern Time and 44 seconds. We went straight into terminal count. Liftoff now 9 minutes away. So terminal count. Control has been given over to the GLS, the Ground Launch Sequencer, a computer and software that is doing all of the commanding and monitoring of the Space Launch System. We'll hear callouts from the GLS operator, Alex Pandalos, as well as NASA Test Director Jeff Spaulding. GLS is pre-tensioning the umbilicals at this very moment. You can see them as they run down the rocket. That's getting them ready to detach. At liftoff, those arms will swing away. We'll let go of the rocket in a clockwise direction. T-minus 8 minutes and counting. The GLS is performing up to 100 commands per second, including configuring ground systems for power transfer to the rocket. GLS is turning on cameras, recording video inside and outside the crew module to collect data for engineers. Purging the aft skirt booster with high-flow nitrogen. Clear out any hydrogen gas that may be there. You can see the crew access arm is already retracted. When there is crew during Artemis 2, it would happen at T-minus 6 minutes. But out of abundance of caution, they went ahead and retracted the arm well ahead of liftoff. I want to point your attention to the base of the mobile launcher. If something wasn't done to reduce the power from the pressure caused by the rocket's ignition and thunderous sound, it could damage the rocket. So the ignition overpressure and sound suppression system will flood the mobile launcher with water. You'll see that sequence start at T-minus 17 seconds. Now coming up in less than 30 seconds, the ground launch sequencer will start bringing the high energy systems online, starting with core stage pressurization. Firing room 1 is completely silent as they listen for the next call.
GLS is go for core stage tank pressurization.
The core stage tank is now pressurizing to flight levels. The replenish valve to the liquid hydrogen tank now closing. The liquid oxygen tank will come a little later. Now we're arming the Orion ascent pyros and transfer to internal power. The launch abort system, or LAS jettison motor, is now armed. On this flight, the abort motor is inactive because there is no crew on board. Up next is the flight termination system, or FTS, which gives the Space Force the ability to destruct the rocket if it goes in the wrong direction. Let's listen in for that.
GLS is go for FTS arm.
The flight termination system is now armed. Coming up at 4 minutes and 40 seconds, a big moment. This is where the RS-25 engines and their bleed go to high flow. It's been a little tricky to dial in.
GLS is go for LH2 high flow bleed check.
Good word, we've passed that. The cryo team got the LH2 engine bleed pressure loop dialed in. They are now at the right temperature for launch. Countdown continues. T-minus 4 minutes, 15 seconds. Up next, GLS fires up the CAPUs. Those are high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25s. Stands for Core Stage Auxiliary Power Unit start.
GLS is go for core stage APU start.
That now leads to the thrust vector control test at T-minus 2 minutes and 30 seconds. That can proceed now, and we will see the engines gimbal at the bottom of the core stage. At T-minus 3 minutes and 10 seconds, you will hear the go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve, getting the air and moisture out.
GLS is go for purge sequence 4.
And in just a few seconds, GLS will close the core stage LOX vent, liquid oxygen. The white vapor cloud caused from the super cold gaseous oxygen condensing the water in the atmosphere will disappear. You see it coming out there now. And there it goes, it's closed. LOX vent closed, pressure rising in the core stage LOX tank to flight levels. Coming up in 15 seconds, look for that thrust vector control actuator test. Engines will gimbal. And there they go. The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket into space. They will operate at 109% performance. Each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. Altogether with the boosters, 8.8 million pounds of thrust.
GLS is go for upper stage to internal power.
Now the upper stage has gone to internal power. So power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery power. The same milestone is coming up for the core stage at T-minus 1 minute and 30 seconds.
GLS is go for core stage to internal power.
The rocket's core stage, which houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2 seconds.
GLS, go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now flowing
15.
under the ML. And here we go.
10.
Hydrogen
GLS,
burn-off
go for
igniters
core stage
initiated.
engine start.
7, 6, 5. Core stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
Engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour.
Artemis flies. Let's bring in Trekzone science expert Dr. Brad Tucker. I spoke with him a little earlier and started by getting an overview of the mission.
The goals are, how do you say this, lofty but low. It just has to work. And that sounds simple enough, but obviously it's not simple enough. The goal here is to make sure the new rocket, the Space Launch System, the new capsule, the Orion capsule, the new orbit, the new trajectory, everything about it from mission design to mission equipment works. And importantly, works not just the way they think it does, but in a safe and operable way for humans, because that's the key. This will be a human-carrying capsule and vehicle, so this needs to be the way that it behaves. And so the threshold for issues, the threshold for problems, etc., is a bit different between one that carries things and one that carries humans, and that's rightfully so. So all of this is, does all of that work according to plan? Do they need any tweaks? Is it really ready to go? This is kind of are we actually ready to go to start sending things to the moon? And that's the goal of Artemis 1.
Very, very exciting. NASA hasn't been able to catch a break, though, and we're just talking about the launch here from the original scrub, the second scrub, a hurricane on Monday as well, just not being able to catch a break. Hopefully today. We're obviously pre-recording this. I'm not ashamed to say that we are pre-recording ahead of time. Life happens. Rocket launches are almost happening every day, but hopefully to the side of us in our pre-recorded window here on the Trekzone live stream, there is Artemis flying. If not, it's another delay. But let's think positive right now. Artemis is flying just off to our side, and how exciting is this?
Look, yeah, as you said, they actually had to weather 2 hurricanes, right? They're not just the hurricane on Monday. There was also Hurricane Ian, because they rushed to get that seal fixed in September for that later September launch, which then they had to postpone again. So, look, there's been a lot of anticipation for this, and people have been asking for decades, are we going back to the moon? And yes, we are. And yes, it's hard. Just because you've gone once doesn't mean it was easy to do again. I think there's always a lot of, well, if they've done it before, and they had the technology, why is it so hard? Well, everything is new and you have to still get it right. Just because someone has built a car doesn't mean you can easily build another car. Even if I was given the plans to have designed a car, I probably couldn't get it to work. So even if people have trained and studied this, they still need to do it. And they also want to improve. All of this is about a new, better, longer way of getting to the moon, very different from the Apollo era. So, it starts with this launch. It starts with this rocket. It starts with this mission. And it's the beginning of a very large amount of, exciting work. We just had Capstone arrive at the moon on Sunday, launched by New Zealand. We have iSpace, a Japanese mission contracted by NASA to start landing equipment on the moon, happening next month. Is it not just this mission, as you're saying, with rocket launches every day? This is the big part of the start, but there's a lot of other stuff happening to make this whole thing come together.
And I think we're finally at the point now where we are looking ahead to the years and the decades ahead, where the moon isn't the ultimate objective here, like the 60s with the space race. Now it's about pushing further. Yes, we can do it. We have done it before. Let's do it again with the technology that we have now. But then let's also push a little bit further. Let's stay on the moon and get to Mars. This is, I think, the most exciting thing for me. This is the space race for my life. For my generation's lifetime. For you as well, Brad. I don't think you're old enough to remember Neil Armstrong stepping on the moon. So this is a very exciting time.
It is, and it's also not a race. Like, I think that's the cool thing about it is, with the Apollo missions, it was a race. Who got to the moon first, finish, it won. But it also meant that the race would be over, and that's what we saw. We often ask, well, why did the Apollo missions end? Well, there wasn't really that, where do we go to next? Yeah, a couple of people talked about Mars, but there was no, this is what we do, this is what we can do. And importantly, the cost was prohibitive. But now, yes, you get to the moon, we stay longer in the moon. We get longer in the moon, we go to Mars. If you get to Mars, you stay out longer on Mars. But then it's also exploring all these other places. We have other missions to the Europa Clipper, as we've talked about before, to Jupiter. We have missions to the Martian moons that we've talked about. And all of these are happening with it. And that's, again, very different than what was in the 60s. So if everything works on Mars, then we will go somewhere else. You will do more. And that's the exciting thing. And again, it's not just also a two-horse race, so to speak, between the U.S. and Russia, the USSR. It's also a collaboration with other countries, but lots of groups doing different things that make it happen and cooperative and having that longer term vision. So I think it's in some ways better than that race in the 60s, and it's very different, so it makes it very special. So even if people remember the moon landing, I'm not one of them, they can appreciate this because it's not just hey, we've already done that. This is a very new thing that we haven't done before.
And when we get there, it will be not just white men bouncing around in the microgravity environment of the moon. Very exciting to have our first woman and our first person of colour also joining the Artemis team when we get to landing. That's Artemis 3 right now, as we're talking about proving the systems, proving the capsule, making sure that everything is A-OK. It's a 21-day mission, I believe it is, splashdown coming back to the Pacific Ocean just before Christmas.
That's right. And again, much longer than what we saw with the Apollo era, which was really 5 days tops at the moon. It wasn't very long. These are longer missions. He said more people. And again, it's not even just Americans. Canada and Europe are in discussion about being on different Artemis missions, not Artemis 3, but maybe 2 or 4 or 5. And even the possibilities of an Australian astronaut in the future on one of the upcoming Artemis missions down the road. And so that also makes it exciting. Again, it's not just a white U.S. male thing. It is a more global effort and a more global representation of getting to the moon, which it's exciting for everyone. And you almost want it to be commonplace, right? We've gotten so used to rockets and satellites going up, but now there's all these new cool missions that happen and we get excited. So you want it to be such a commonplace thing. Every mission is unique and you focus on not that we're going to the moon, but hey, we're sending a rover or the space station's operating or all these different things that are literally in the works right now. And that all happens if Artemis 1, this all works.
Absolutely, and I love that Australia is not just necessarily a supporting role in this. Now we have an Australian Space Agency, a government body that can represent our interests moving forward. We do have a ROSE, which will have the Australian lunar rover happening on Artemis missions in the future. But as you say, Australian astronauts are a possibility. We have this government body that's championing Australian industry and stuff that we can be doing, not just sitting back here with Glenn and friends down at Tidbinbilla receiving stations. We can be amongst the groups transmitting as well.
It is, and we also undersell some of her contribution in the Apollo era. It's also the science, and we've talked about this before, that follows through it. Those moon rocks that they brought back to understand the age and composition of the moon, the scientist that figured it out was Ross Taylor, who worked at ANU. He passed away, sadly, last year. NASA went to him for help. We've had people who have been the science people on Hayabusa 2, as we talked about, Perseverance and other Mars rovers. So these are the sorts of things that were going to happen as well. We have groups, including here at ANU, I've talked about how we can put a telescope on the moon as part of these missions. And this is where the body of work is happening and changing. And so you're right, it's not just going to be we're only doing communications. We're going to be involved in the science. And because there's going to be a lot more science with these Artemis missions, because 40 tons, that's a fully loaded truck on the road. That's a lot of stuff, right? That's a lot of stuff getting to the moon. And that's the exciting thing. That's a lot of science. That's a lot of payload. That's a lot of equipment.
Now, one question that I do ignore, we have answered it on Talking Science in the past. We've been going for 3 seasons. That age-old question, inevitably people come along and say, that's great, but we should be focusing on Earth. We should be fixing the problems here on this planet before going and messing up another one. As I say, we've talked about this in the past, but once again, because it's going to come up again here with Artemis, why bother going to the moon? Why should we not just be focusing here on Earth, Brad?
Yeah, look, the question always says that you can't do multiple things, and that's obviously a falsehood. And yes, we have lots of issues here. Lots of those issues need to be solved by advanced technology as well that we develop for all these programs. A lot of the sensors and cameras that are developed for these missions are being used in things for monitoring the floods and future and bushfires. And then even the random things that we just don't think about the development. Memory foam. It's a simple thing that we've used to make sleep comfort. That was the space shuttle, right? Prostheses. So much development has happened from that based on the material and the work that we've happened on the space mission. So you get all these spin-offs, and I think it's always good to talk about the spin-offs, but we also always fail to realize the exploration and investigation and the inquisition that we have as a species, that is natural to being human. And if we don't appreciate that, and if we don't do that, then we kind of lose the huge part of what it means to be a human. And that is a very important thing to do. And the only way we can feed that is to find new ways of exploring the universe, which is this, but then also the byproducts that we get from that then have those tangible benefits. So it's kind of a whole package that we have of why these things work and of why these things we need. From inspiring people to, there's a reason people can watch this live stream because the technology was developed for space. That's why.
Yeah, exactly right. And on a small level as well, I take away what William Shatner said following his launch on Blue Shepard with Bezos a few months or last year, where he looked back at planet Earth and said, my God, this is a beautiful place. And if one person traveling into space can do that, imagine what bringing back 4K imagery from the moon, looking back at our planet and going, everyone that you know is on that blue dot in that sky. All we need to do is inspire some generations of upcoming scientists, even current generation of scientists as well, who are already working hard but finding new ways of doing stuff. As you say, these spin-offs from the space exploration, that's just one part of it to addressing these issues as we move forward here on planet Earth. Brad, a quick one for you. What are you hoping to see out of Artemis 1 with this demo mission? I guess what's kind of the highlight that you're looking forward to?
I think it'll be cool when we get those CubeSats and other satellites dropped off on the way. Again, we don't think about that, but there's a lot of satellites that are going to do a lot of science that are piggybacking away that will be dropped off at two different spots along the way to the moon. So that's going to be really cool. Establishing that kind of new orbit around the moon, the physics is quite hard, and it's quite important to get it right. So that's going to be an achievement unto itself. And again, that's not what the Apollo program's done. That's not what other satellites have done. So I think there's a few of these technical things that are really cool that are going to happen. That again, just as in the Apollo mission, it was, hey, people landing on the moon. It wasn't as focused on, hey, let's leave some science experiments that have literally transformed our view of the creation of the moon, how the Earth and the moon evolved, and how the solar system evolved, all because of those simple decisions and those little bits that tagged on along the way. And that's the same here with this. Who knows what these satellites will enable and discover and what that orbit will mean for future space travel, all because they are able to knock it and perfect it with Artemis 1.
For me, I'm loving this potential that by the end of the decade, we can look up at our biggest object in the night sky and know that there are people there, that this is the aim that we're getting to. We're going to be putting a space station in orbit. All of the physics that are involved in that to establish lunar orbit, just to get Artemis 1, even this very first mission, to get that there and get it orbiting and then bring it back, all by remote control, is just incredible. The feats of engineering involved in this. Yes, SLS has run over time and over budget. Yes, this is the fourth launch attempt, but I tell you what, none of that matters because, as I say, we are pre-recording. Hopefully there is a live shot of Artemis flying high into the Earth's atmosphere right now, and that is all that matters right now.
Yeah, look, it's easy to reflect on the delays and the issues now, but in 5 years' time, You don't remember that. People don't reflect on Apollo 1, right? We think about Apollo 11, we talk about that. Apollo 1 ended in tragedy, with 3 astronauts losing their lives. And obviously it was a great loss, but we don't reflect on that. Obviously we do memory, but you don't say, oh, the Apollo mission was a fail because of Apollo 1. No, you say the Apollo mission success because we landed people on the moon. And that's going to be the same case with this. You won't reflect necessarily on those little bits and wiggles along the way. We don't reflect on SpaceX having blown up so many rockets to get the Falcon 9 to work. We just think about how cool it is when it comes back down and land. It's all of that little bit development that comes along the way that makes it a success. And it makes the mission work. And so you will reflect on the success, and this will be a footnote in the history of the moon travel.
It absolutely will. Brad, looking forward to wrapping this all up with you in December's edition of Talkin' Science with you at the start, the first Tuesday of December. Looking forward to that. Then I can't believe that's December. That's the year done. Right now, though, just incredible.
Look, it is. It's good to see it fly. It's good to see it happen. And it'll good to follow for the next few weeks. Like, that's the cool thing, right? There will be a mission going around the moon with a human capsule, not carrying humans, but dummies and Shaun the Sheep, in space, for the next few weeks. That's kind of cool.
Absolutely. Thinking positive here in our pre-record. I love chatting with you, Brad. I'll catch you for Talking Science at the start of December. Right now, let's get back to watching Artemis fly, hopefully. And there we are. Artemis has flown. We have successfully, well, NASA has successfully launched the SLS, the Space Launch System, after 3 failed attempts. We are now hearing that the rocket has reached main engine cutoff, MECO. That is in the mission timeline. The RS-25 engines have powered down. The core stage has separated, and Orion is in Earth orbit. That is how we are going to wrap up this Trekzone live stream. We're fast approaching 1,000 episodes, so be on the lookout for that in the middle of next month. And as I just said, Dr. Brad is here on the first Tuesday of every month to bring us a roundup of the biggest stories across the past month. I've got your bite-sized wrap-up the other 3 Tuesdays, just like this episode. Thank you for watching this edition of Talkin' Science. We did it live. I am Matt Miller. I will see you in the comments, just clearing off all of my screens so that I am ready to roll that closer. Thank you very much for watching live. I know you have your choice in NASA launch live streams, and many people catch these in the future as well. So hello if you are watching it in the future. Thank you very much for checking us out. This has been our live coverage of Artemis 1 launching. I'm Matt Miller. As I said, I'll catch you in the comments.